Last time, we talked about replication, how to keep your data safe. But if you copy the same data everywhere, you might end up with a system that's more fragile than a glass house. What if your database could predict which parts of your data would crash your system before they even got there? That opens up the real question for this episode. How do you split your data so it's both fast and fair? Here is the framing that makes the rest of the episode easier to hear. We are not just naming concepts here. We are trying to spot the moment where the system starts pushing back. How do you split your data so it's both fast and fair? Picture this. Imagine you're building a database for a library of books. You split the books by the first letter of the title, but then you realize the Z section is way too big. It's like having one shelf for all the books that start with Z. It's just not balanced. Where it gets tricky is this. You can't predict how data will be used. A simple split can lead to uneven workloads. The useful shift is this. Partitioning by key range is simple, but it can create hotspots if your data isn't evenly distributed. So the design move is this. Use dynamic partitioning or add a secondary key to balance the load. Take this moment. You're trying to build a system that handles millions of user requests. You decide to use a hash function to split the data. It works until you realize the same hash value keeps getting assigned to the same partition. The catch is here. Hashing can help spread the load, but it can also create collisions and uneven distribution. What should really land is this. A good hash function makes data look random, which helps avoid hotspots. So the practical move is, use a consistent hash function like murmur hash or MD5 for predictable partitioning. Imagine the system on a rough day. You're building a system to track sensors in a city. You use timestamps as keys, but all the data ends up in one partition. It's like trying to track 1,000 birds with one net. This is the part teams usually feel too late. Timestamps are great for ordering, but they can create a single point of failure for writes. The deeper lesson is this. Partitioning by key range can lead to hotspots if your data is time-based. The engineering response is, add a prefix to your keys, like a sensor ID, to spread the load across partitions. Here is the version that shows up in production. You build a secondary index to make queries faster, but now your index is causing the same partition to get overloaded. It's like building a shortcut that leads to a traffic jam. And here is the pressure point. Secondary indexes can speed up queries, but they can also create new hotspots. The thing to notice is this. Partitioning secondary indexes by the same key as your main data helps avoid duplication and load imbalance. So what do you change? Start here. Align your secondary index partitioning with your primary data partitioning strategy. Now zoom out. Partitioning is the invisible hand that balances speed, scalability, and fairness in distributed systems. One more quick lens helps here. Your system is growing, and you notice some partitions are getting too big. You try to rebalance, but the process is slow and disruptive. It's like trying to move a mountain with a spoon. Automated rebalancing can help maintain even workloads without manual intervention. If there is one thing to keep, make it this. Choose your partitioning strategy like you choose your team. Know your data, know your load, and be ready to adapt. Now that you've split your data, you need to make sure it's not just split, but also working together without breaking anything.